Good morning, class. Happy morning, afternoon for those later periods. It is June 1st, and sorry I can't be there. I'm down in 428 helping to set up for the 8th grade science exam. You guys are all looking forward to for next year. Today you guys are going to work on using a new equation to help solve motion problems again. And the equations we're going to be looking at today are to solve for momentum. And so let's take a look at what that is. And so the first thing I wanted you guys to do to get a feel for momentum, I think where momentum came most real to me was playing bubble soccer against some students last year, and it was an absolute blast. And it was one of those places that it was really interesting to look at the science in action. And so we're going to watch some bubble soccer. And as we guys are watching this, on the packets that you guys have at the top, there's 3 questions I'd like you to try and answer as we're looking at this. So when you're watching bubble soccer, what makes one person fall over and the other not? So you're going to watch them crashing into each other. Watch and see, can a small person knock over a larger person? And if they do, why can they do that? And the last question is, how does running help you knock over someone else? And so let's take a look at what bubble soccer is if you haven't seen this before. It's hysterical. Oh, that's fun. There you go. So I got to play this, if you want to call it a sport, against seniors last year over at Romulus, and I tried to explain to them a little bit of the physics going into this game, and many of them decided that they were going to destroy Mr. Straub, and it was going to be so much fun to knock me over. However, I didn't get knocked over all that much, and if we can understand a little bit of the physics about what's going on here, you might understand why. So if you guys watch these guys, you can tell some people are standing up and some people get knocked over. And so what is the physics behind that's going to help us understand why it is that someone goes flying and someone generally can stand up? And so what we're looking at here is momentum. It's that transfer of energy. That, like other things, it can't go nowhere. It's got to go. Has to go somewhere. And so as these guys are running into each other, we'll see through these equations hopefully today why one person's not getting knocked over and the other one's standing up. So momentum, like other things that we looked at this year, has a conservation of momentum. So it's not going to disappear, and so it's going to get transferred from one object to the next. And so let's take a look at what the math looks like for momentum. And so momentum, when we're talking about it is a measurement of motion, and it's a measurement of motion including 2 things. It's the mass and the velocity. And so the way that you can increase your momentum, the way that you can knock somebody else over, is to change either your mass or your velocity. And so unfortunately, most of those kids couldn't change the mass very easily. And so the only way to really knock somebody over is to get going really fast. If you can increase that velocity, then you have a better chance at knocking somebody else over. And so going back to those starting questions, what is it, what makes one person fall over and the other not? It's momentum. And so the person with the larger momentum is generally going to be able to transfer that energy in the direction of their momentum. And so can a small person knock over a larger person? Absolutely. If they have enough velocity, they can. And how does running faster help you knock over someone else? Increasing that velocity is going to increase your momentum. And so let's take a look at some of these questions and what they're going to look like. This is the triangle of science we're going to use for momentum. And this is like the other ones that we've used, where we have P, which stands for momentum. And I know it's not an M, but unfortunately we already have an M in the equation. We're going to have to use mass here. And so momentum is a product of the mass and the velocity. And so these are the 2 things that we're going to multiply together to solve for a momentum. So again, that looks in the triangle. Remember, if you cover up the P, and then you get the equation, which is mass times velocity right here. So let's take a look at what one of our questions might look like here. And so this is a typical momentum question. A 0.14 kilogram baseball is thrown in a straight line at a velocity of 30 meters per second. What is the momentum of the baseball? And so here is, we're solving for P. The units we're going to use for momentum is kilograms per kilograms times meter per second. We're going to use mass in kilograms, and velocity is going to meters per second. And so in this question up above, our mass, we can just plug that in. That was 0.14 kilograms. The ball was thrown in a straight line at a velocity of 30 meters per second, so that's our velocity. And then we're going to look at our triangle, and then we're going to, remember, cover up the part that we don't know, and then check and see what our equation is. And so in this case, our P is our unknown, so we're going to cover up P, and that's going to tell us our equation is going to be mass times velocity. And so we're going to use the math of 0.14 kilograms times 30. And let's take a look at what our math looks like here. So if you take that 0.14 kilograms and multiply it by 30, you will end up with our momentum for this question, which was 4.21 kilograms times meters per second. All right. So these questions are going to be a couple more of these for your homework today. So I want you guys to take a look at this next one here. Again, we're going to set this up the same way. Go ahead and pause the video. Once you guys feel like you have answered this one, go ahead and have the substitute teacher check your answer. And if you guys can solve this one correctly, then we will hand out today's packet that you guys can work on for the period. So go ahead and pause it, and as you go through, you can walk through the class and check. Thanks. Alright, so this one was slightly different than the last question, and so let's take a look at what we had to do on this one. And so the wiffle ball was thrown with a momentum of 0.002 kilograms times meters per second, and had a mass of 0.001 kilograms. What was the velocity of the throw? And so again, we here have a momentum was given and a mass was given, and we need to solve for velocity. And so we need to take a look at our triangle of science here, and we're going to cover up velocity because that is what we don't know. And so our equation is going to become here, it is going to be momentum, which is that P, divided by mass. And so our equation is going to be 0.002 divided by 0.001. And our answer for this question, velocity, was 2 meters per second. All right. You guys have some questions to answer about momentum. Whatever you guys don't finish in class will be, of course, homework. You guys can, again, as usual, work in groups of 2 on the packet. So find someone that you feel comfortable asking questions, talking with. Make sure that you ask people around you before you ask our substitute for any extra help today. Make sure that you guys remain seated for the entire remainder of the period. And if you guys happen to finish early, you guys should take out a book and read. Else you should be working on this packet up into the bell. And that means we're productive for the entire time. I'll be checking in when I can. Okay, guys, good luck. Thanks.